Hello, everyone, and welcome to the overview of the devices that we have in the laboratories and their technical specifications and software development kits. So, here we will be going into the details of beacons, the TI sensor tags from tester instrument, Amazon Echo Dot, the famous Alexa, Microsoft Kinect webcam, and the eye tracker devices. One very simple eye tracking device that we have in the lab and that it can be used for very simple but useful applications. And brain computer interface, balance board, sensor wristband. In particular, it's the Mi band because it's been reverse engineered some years ago, and so it's easy to use at a very very technical level. So what we'll be providing here in this presentation is the scope for the device, some underlying operating principles, some additional hardware details if available, and the software development kits that you can find over internet, and an overview of application development and sample laboratory tasks. So what is a beacon? A beacon is a tiny Bluetooth radio device that can act like a lighthouse. So you can receive from these devices short, very short messages at regular intervals, and these messages bring a special ID that it's unique for every device that can be used to tag a position and maybe use by means of special application and maybe be used to to retrieve important information about the position or the location in which it's placed. As for instance, in a museum, you can use a beacon to tag a different piece of artwork and enable visitors to retrieve from the specific application additional information that cannot be available. So, what are the operating principles of the beacons? Well, they are based on, they rely on Bluetooth Low Energy Protocol, which was introduced late in 2014 with Bluetooth 4.0, and it's kind of a wireless personal area network technology which is used for transmitting data over short distances because the Bluetooth typically connects devices up to 10 meters distant, and it is designed specifically for low energy consumption. And this is done without any impact on the communication range. It's generally cheaper than traditional Bluetooth, and it's the best solution for application requiring small periodic data transfers. So, and moreover, it can be used with some easily the well some easy application, very easy application can be used for indoor localization. So Bluetooth operating principles again are based on small packets called advertisements that are broadcast at regular intervals from the device. It's a simplex communication. It's one-way communication because it's one point to many other points. It's a broadcast in which the advertising packet is sent through and can reach up to 100 meters far devices, but it's generally not used for such long distance because the tracking becomes less precise if you want to retrieve the distant, the range at which it is placed, because it is also possible by means of a not very precise equation because it has not been disclosed by Apple, who invented the beacons. What is the the, the equation that is used to compute the distance from the transmission power, but it can be more or less estimated with some precision. And as long as it goes farther, the precision gets lower. And here you can see that you can also use an iOS device to behave like a beacon, a dedicated hardware device. A typical scenario in which you can use those beacons is retrieve the ID from the beacons that is placed in a specific position in a store, and then inquire a database server, a remote database server by means of a mobile application, and retrieve the relevant information that is specific maybe for the customer. So maybe this customer may have a special discount for because it's a very good customer, and so they want to reward the customer. At the physical layer, the Bluetooth Low Energy works on the 2.4 gigahertz ISM band. ISM stands for Industrial, Scientific, and Medical, and there are specific channels used for advertising that are selecting at different positions because they want to avoid the interference. You know that radio signals can interfere between them, among, well, close signals can interfere, and so here they are placed in a position, so that they are not interfering with each other. Please, you can also see in the picture that there are some specific ranges in which that are covered by Wi-Fi channels as well. Uh, there are possible states in which a Bluetooth device can be, and specifically they can be in standby, so they're not transmitting or receiving anything. They're so in power save mode, and in this case, the energy consumption is less than 2 microamperes, which is very, very low. And that's why the batteries can last up to 2 or 3 years, depending on how you use the devices. When they are in advertising mode, they send packet in broadcast on the advertising channels and listen to any response from CAS scanning devices. And so other devices like mobile phones can be scanning the net to retrieve advertising packet that are broadcast over those channels. So the advertising packets, you see that they are sent periodically, but the time interval is not always the same. There's an average delay, which is generally typically set in a constant value, which is from 20 milliseconds to more than 10 seconds. And then there's a random value that can be added to this advertising delay in order to avoid, reduce the possibility of collision from different devices, from the advertising packets that are sent from different devices. So this is the structure of the advertising packet, in which you can see that there are also the codes from well, the operations or the states in which the device can be. And we are interested more into the payload in the advertising channel PDU. PDU, it's packet data unit. So here, what is into the payload? The payload carries information about the MAC address. MAC address is a universal unique identifier, which is a 128-bit, 16 bytes number in the format specified in the format 42226, and which in hexadecimal is reported in hexadecimal format. You can see an example here. So beacons generally do not allow for connection. But there are some cases in which they can be also connectable. It's not so infrequent. There are also inside the packet, the payload, there are also two numbers which are, well, the most important fields that we are going to use for our applications are major, minor, and the transmission power. So we use the UUID to identify which packet it is, which device it is. Then we can use major and minor fields to set, well, to identify, maybe, let's say, it could be major number could identify a room in a museum, and minor can be identifier of the different piece of artwork in each of the rooms, because it's 2 bytes, so we can have uh, well, 2 bytes is more than 65,000 values, so it's a lot of devices that can, well, a lot of items that can be tracked by means of this. But again, it's a custom usage that you can do, and the transmission power, it's used as a reference value because it's useful to track the distance of the device and identify which one is farther or closer. The two most common protocol that are used for beacons are iBeacon, which is the first protocol that's the most widely used because it was invented by Apple, and it's natively supported in iOS. And the new version, another new protocol, newer, is Eddystone, which is an open communication protocol developed by Google with Android users, for the Android users, and it has extended functionalities in addition to those that are provided by iBeacons. Okay, the application development depends strictly on the target platform. So you can see here that there are a lot of useful resources. One thing that you need to pay attention to is that if you work on Linux, well, in order to be able to scan a device and to access the device, your application must be run as root users, so must be an administrator user. Otherwise, you cannot get connected to the device because the device is a special file in the dev folder, and so it's not easy to connect if you're not, well, it's impossible, not easy. It's impossible to connect if you are not root. Again, here you have also resources for Windows, and now we can move to the new device. Another device is the sensor tag, which is based on a special microcontroller from Texas Instrument, and again works on Bluetooth Low Energy Protocol, but it can also work on ZigBee or 6LoWPAN. And it is very interested again because it has many sensors and can be connected to applications, can be connected to application to retrieve information from all the sensors that are inside the device, and also can be used to connect on cloud, can integrate with many mobile applications very easily. So this is one of the pictures of the device, because there are two different types, but this is the most recent one, in which you can see you have, it's a very small device, it's not very, very big, but it carries a lot of interesting sources of information and sensors. So here you can see that you have a buzzer, you can have a green LED or red LED that gives you information about the status of the device. There's some user button that can be used to set the different transmission modes, and there are interfaces that can be used to well, that are used for from the sensors inside. Okay, here is the other the other detail. So you have a temperature sensor here, which is placed on the board and retrieves information about the outside temperature. There's a motion sensor, 9-axis motion sensor. There's okay, here is the microcontroller. There is a humidity sensor. There's an integrated antenna for transmission. There's well, another radio frequency connector for external antenna. And here you have also an altimeter or pressure sensor. Well, it's a pressure sensor more than an altimeter, but it can be used also to identify the altitude. And there's also an ambient light sensor. So you see that it's very, very full of stuff, and it's very interesting. You have also, apart from the batteries here, there's also the possibility of connecting to an offline data storage by means of this serial flash. There's a magnet field sensor. There's a microphone, so you can track also sounds. And also there are some interfaces for connecting to other devices and debugging and programming the device. Okay, so it's very, very small but very, very powerful. And here you have a list of useful resources for development. So there's a Texas Instrument. There's a lot of information in which you can understand how it's broken down, what are the devices, what is the sensor structure, and how you can hack the device. You can hack the device to develop your own application. There's also a demo application for Android in which you can see the code. It's not very easy to understand how it's structured, but anyway, if you have time, you can analyze the code and maybe implement additional functionalities. So now we move to Amazon Echo. Amazon Echo is Alexa. We all know it as Alexa. It's a personal assistant, voice controlled, and it has a lot of interesting features like voice interaction, music playback. You can ask for weather traffic information, create your to-do list, set alarms, and most interesting is to be able to control smart devices on connected in Wi-Fi by means of your voice. You can also connect it to the Xbox or other consoles to perform actions like starting applications, maybe pausing or rewinding movies in Netflix, and so on. So it requires a wireless connection because voice recognition it's based on the Amazon Web Services. So you need to be connected, otherwise voice is not recognized. But it's easy activated with a wake up word, which is either Alexa or Echo or computer, and the services, if you want to develop new services, you can develop new skills for Alexa that can be easily if you stay at the standard usage of the device. It can be easily developed by means of Alexa Skill Kit, and it has native multi-language support, but it's very, very easy to use it if you want to do basic things. But if you move a step forward and you want to create something which is more effective or that does something different, things get really complicated. Here is the hardware detail. So you can have volumes, buttons, you can have microphone, you can have action button or to pull down the volume. And there's an interesting light ring that gives you an hint when it triggers, when it's listening. That so you can understand that Alexa is active and it's listening. And there are also power ports to for power supply, and a 3.5 millimeters audio output to connect other external devices. And also it can be connected by means of Bluetooth. Yeah, there are different flavors of echo devices that all support voice interaction, and in some cases also video feedback. And the other specifications that are common to every device are dual band Wi-Fi for 2.4 and 5 gigahertz, Bluetooth A2DPE for audio, Bluetooth video remote control profile, which is again to control the video and remote devices by means of Bluetooth. There's a built-in speaker for sound, for producing well broadcasting sound, and it has a 7 microphone field array, which is very powerful and can retrieve sounds from every play all around the device. It's it has a very nice multicolor light ring that gives you a lot of information about its behavior. The skill kit, here you have the references to the skill kit, and one thing that is important that you can program it by using many different languages such as Python, JavaScript, C Sharp, but you need two accounts. There are two accounts. One is the Amazon Development Console, which is free, totally free, and so you can register very easily. But if you want to use the backend, you also need the Amazon Web Services for the AWS Lambda services. And here you have to provide a credit card, but if you stay into the free tier, you have 1 year of free experimental usage, but there is also a free tier in which if you stay under 1 million transactions per month, well, you don't pay anything. And then otherwise you are charged on your card. So you can really read it carefully just to be sure that you know what you're doing, but you can go and experiment very easily without spending a single pound or a single euro. Uh, Video tutorials are available on YouTube, but again, they are all based on the standard feature set. If you want to do something a bit different, you need uh, to struggle a bit to find something on internet. The Kinect. So Kinect, it's a natural user interface device which can be used by means of gesture or speaking. It was the very initial, well, it was a good product from Microsoft that was used for consoles, but for playing maybe, but can be connected also to the PC by means of the USB connector, and it's very useful for impaired people to be able to allow the usage of computer. So there are some other requirements that need to be satisfied before you can use it, but they can be checked at this link. And the key features of this device are that it has a full high definition color, uh, and it has a wider horizontal and vertical field of view. It can retrieve also depth information about the image, and can uh, track and range items in view. So it's very useful and powerful device that can be also accessed in a simultaneous way by multiple application by means of connection to the server. So this is the high level architecture. You see that there is a physical Kinect connection, physical sensor that is the Kinect, and it's connected by means of driver to the runtime, and then you can develop application in uh, different languages by means of the Windows real-time API. And you can also develop .NET or native application with native API, but this is more complex. The, the thing is interesting, the interesting thing you can do here is that you can connect the Kinect by means of a server. So there's a service that is connecting to the physical device, and every Kinect reader connects to the service. So the application have the possibility of, many applications have the possibility of reading the information from one single connected source by means of the Kinect XDK, which is the intermediate layer. So these are examples of the frames sources that you can have. You can have color, 30 frames per second. You can have with higher resolution. There you can have depth information. Here you have the infrared sensors. Here you have body index. You can automatically have this kind of information from the camera. You also have body information and audio information that it's retrieved by the microphones. So data audio is captured over a specific time interval, and it's associated to what they call an audio beam. And then you can have multi-frame source information, so you can read the information from many different sources at the same time. And the only problem is that the frames are delivered at the lowest frame rate that you can have from the selected sources. So if one of the sources provides 15 frames per second, all the information you get it's 15 frames per second. There are different coordinate systems, and there is a coordinate mapper that can help you to convert each system of coordinate that it's provided above. The structure in detail is that you have an RGB camera on the left. There's a depth sensor here. You have infrared emitters that are used to retrieve information about the infrared for the infrared sensor, and there's a power light. Here you have a microphone array, and inside you can see which is here there is the depth sensor and the infrared emitters. How to use the Microsoft Kinect. So the main flow is that if you have a Kinect sensor, you create an instance of a variable for the Kinect sensor, and if it is available, you can open it and then perform whatever action you want to do. One of the example is to read the data from the sensor, and then close the sensor before leaving and before closing the application, before exiting the application. And so here you have the sensor provides data to a source, to the source has a reader and the frame, and then data that is provided to the application for processing. Okay, so here is an example of what you can do to read and access data from the sensors. The application lifecycle here is all the readers can access a Kinect by pulling. So you open reader and you read the latest frame, or you can also track events. So you register an event, well, how do you say? You register an event manager, and when that event happens, so you have a new frame, okay, on the color device, this callback is activated, and here you can do whatever you want. So one is reading, so you read on demand the devices. Here you wait for an event to happen. Here's a list again of useful application, and there are some interesting books as well for learning how to program with the Microsoft Kinect SDK. So I would suggest you to get into this reading before you start developing, even if there are a lot of examples, very useful example that you can try if you want to do something specific. Eye tracking devices. Here we are talking about tracking the eye movement. So we can track the gaze of a person that looks around the screen and identify which part of the screen is looking at or she is looking at. And also you can use the gaze as a pointing device. So you can use these devices in healthcare to analyze the eye movement for the early detection of some neurological or psychiatric diseases. It can also be used to analyze dyslexia or to analyze the movement for dyslexia and so assess reading disorders because you study the saccades or which means the quick movements that are describing trajectories on the screen and so where the eyes go and the fixations which is when the gaze stands on a certain position and on a certain part of the screen. This device is very small, it's very portable, and it combines a very high resolution camera with infrared because infrared are reflected by the inner part of the eyes, and so it's easy to track the position of the eye by using infrared. And it requires at least a USB 3 because of the transfer rate, which is very high. You do not require any separate power source. It's simply powered by the USB. But one drawback is that every new user has to undergo a calibration because every person has a different position of the eyes, has a different reaction to the movements, and so on. And again, if you want to use it effectively, the head of the user should be kept more firm, well, should be kept in a fixed position because this allows to track only the eye movement because you can turn your head and the eyes can stay in the same position but move the head. So it's preferable to move the eyes and not the head. So there are two components. One is the server and the other one is the user interface. And is the client application because the server delivers data to every application which is connected. So they read the data from the from the sensor and translate it into events that are sent at regular intervals to the user. So there is no official data about the hardware structure. It can work at different sampling rates at 30 hertz and 60 hertz, which is very, very low if you want to do professional application, but it's very useful if you want to do well, some application that do not require the tracking, the precise tracking of the eyes. There's a 0.5 degrees on average accuracy in the gaze detection, and it can work on screen sizes up to 24 inches. So if you have a wider screen, you cannot use it because it doesn't give you any good answer, and you cannot even calibrate the device. So you have an API and SDK which works in C++ or C# and Java, and you can find here The tracker software, it's based on an open API and transfers JSON messages in an asynchronous way because they are exchanged via TCP sockets to multiple connection, multiple clients, but you receive JSON records that can be parsed to understand what are the information provided by the server. The coordinates are defined in pixel from top left top left oriented to the system as useful as a use not useful as usual because generally you have 0 in the top left corner and the pupils are tracked in different positions, so it's not so easy to to map it. You have problems. Again, anyway, they are set in a top left oriented position. But every operation is done by the server that provides you enough information enough information and translated information to be used for your application. The default server port is the one reported here on the localhost, and the tracker server can again work in two possible modes. Push, so like in the Kinect, the user receives frames in a continuous way, or pull, in which the client is expected to request the new data. So you remember that in one of the cases we were tracking events, so it's push, and in the other case you request the information to the server. The request message is a JSON structure in which you have this required information. These attributes are mandatory, and you receive a response message that contains again some required information that are copied from the requesting message, and then additional response that it's in which you can also read the status code. The status code is compliant with the HTTP status codes. So the state of the SDK tracker is embedded, you see, in the frame object, and it's in the state value. Again, a client is connected to a tracker that is connected to a tracker should always send an hearted message because the server has to know that this client is still alive. And here you have some resources you can look at to understand how it works and how to use it in a deeper way. Anyway, there are also open source tracking libraries. You can do a lot of interesting experiment with this device. Brain-computer interface, we have this NeuroSky MindWave headset. It's, again, simple and lightweight. You can monitor some brainwave signals and retrieve some information that can, well, some data that can be used for applications like games, toys, or for health and wellness applications, or also for education and research. It's not a very professional device, but it's interesting and useful for some experimental scopes, goals. We have one electroencephalograph channel, and it's based on this TG81 sensor chip. It works with very low-level signals. It is immune to noise, and it provides a very raw data set that it's on 12 bits at a sample rate of 500 hertz. And you can also monitor all these wave bands that are typical from the brain. You can measure attention level in intensity, like mental focus, and you can also measure the intensity of relaxation. And it has also a functionality of eye blink detection. The developer tools are available for all the platforms, and there are interesting hacks also available for Arduino and Raspberry Pi. And there's a lot of examples and libraries on GitHub, so you can have plenty of examples and application to use this device. The official resources are in Mindwave, and so you can have this is the official site. You can see other resources here and maybe download the specification, the data specification of the biometric sensor. The Wii Balance Board, again, is a game controller that can be connected. Well, it was originally developed before the Nintendo Wii console, and it connects via Bluetooth and exposes all the same services that are available in Wiimote. Wiimote, okay. So you can also look for this in this website. There are a lot of interesting information about the Wiimote controller. It uses a 4 said 16 bits pressure sensor to measure the center of balance and the weight up to 150 kilograms. And we have pressure data in big endian format, and the calibration data is available unencrypted in 24 bytes of data. And they present the same status information as Wiimote. So if you look at the technical guide of Wiimote here, you have a lot of additional information and details. And it's very interesting to use to maybe hack the Wiimote device because you can retrieve a lot of information. Again, the balance board has its specific information and the hacking tools. And here you can see additional programs or examples. Again, here for Python, you can use Python, you can use board in Linux, and so on. And finally, we have the sensor wristband, which is the wearable device that typically has a different range of prices depending of the features that they provide, but there are very, very cheap ones like the Xiaomi Mi Band 4, which is very powerful and cheap. It costs no more than 30 euro. And it can be used to track steps and fitness activities, track your sleep, and other biometric indicators such as heartbeat and so on. And you can also estimate calories burned at a distance covered and report mobile phone notifications or messages for incoming calls. But the main problem here is that most producers do not disclose their SDKs. We are focusing on the Xiaomi Mi Band because the protocol has been reverse engineered some years ago, and so there are various applications that you can find over internet to see how to use it. The specifications are those listed here. It's water resistant, it has vibration, it has low cost, it can track heart rate but is even if it is not in continuous monitoring, which is maybe a kind of drawback. And it has a very long standby power. And you can also use it with Android in very easy way. So this is the hardware information about the Bluetooth. It's difficult to read here because it's written in very small, but if you look carefully, you can see what are the devices that can be that are available on this wristband. Uh, Again, here is everything you need to know about the Mi Band protocol, Bluetooth LE. There's Python libraries for connecting, the notifier, and also some tricks to obtain heartbeat live monitoring. It's important to note that if you use a heartbeat live monitoring, you reduce the duration of the batteries because of the increase in the power consumption. And that's all. Thank you for your attention.